Hey everyone, my name is Fabrizio, and in this video I'm going to be showing my thought process behind how I solved this ABC question on exam 2. So this question is essentially asking you three things. It's asking you the capacitance of this combination of parallel plate capacitors made from two plates 12 centimeters on each side and 4.5 millimeters apart, with half the space being filled by plexiglass, which has a dielectric constant of 3.4. And this whole setup is connected to an 18-volt battery. So it's asking you A, the capacitance of that combination, B, how much energy is stored in the system, and C, it's asking you how much energy will be stored in the system if you remove the plexiglass. So this is the work that I did on the test in the moment. As you can see, I had already set up my little diagram, and I listed all my values here. So side length obviously is 12 centimeters, which is just 0.12 meters. And to find the area of those two, you just square that side length, and it gives you 0.0144 meters squared. The distance between those two plates is 4.5 millimeters, which is 4.5 times 10 to the negative 3 meters. And then obviously volts equals 18 V. So for part A, basically what you want to do is you want to divide these two sides with this. I consider this side 1, and I consider this one to be side 2. So side 1, since there's a dielectric in there, you want to use this equation. The C1 equals KC naught. And then you're going to set C naught equal to epsilon naught times A over 2, since you're only using half of the area of the system over the distance. So it's just going to be 3.4 times epsilon naught, which is 8.85 times 10 to the negative 12, times 0.0144 over 2, and all of that over 4.5 times 10 to the negative 3. And that is going to give you 4.814 times 10 to the negative 11 farads. So C for this side is just going to be that, except without the K constant, since there's no dielectric in there. It's going to be epsilon naught times A over 2 over D, which is going to be epsilon naught 8.85 times 10 to the negative 12 times 0.144 over 2 over 4.5 times 10 to the negative 3, and that's going to give you 1.416 times 10 to the negative 11 farads. So to find the total capacitance of that entire system, you're just going to add those two up, and that's going to give you 6.232 times 10 to the negative 11 farads. And so to solve for the potential energy of that system, it's really easy. It's just U equals half of the total capacitance times V squared, which is just going to be 1 over 2 times 6.232 times 10 to the negative 11 farads times 18 volts squared, and that's going to give you 1.01 times 10 to the negative 8 joules. And so for C, if you remove the dielectric, it's just going to be A, because there's no division between the systems, so it's just one whole system. So you don't need to divide the area. So C nu is going to be epsilon naught times A over D, which is just going to be 8.85 times 10 to the negative 12 times 0.0144 over the distance, which is 4.5 times 10 to the negative 3, which equals 2.832 times 10 to the negative 11 farads. And so to find the potential energy of this new system, you're just going to use the new capacitance. And so that's going to give you half of C nu times V squared, which is going to be 1 over 2 times 2.832 times 10 to the negative 11 farads times 18 squared. And that's going to give you the new potential energy, which is 4.59 times 10 to the negative 9 joules. So there you have it. That was my thought process behind this question on this test.